to this episode of the stream, rather streaming series. Today we are going to see how much work we're going to do in terms of a bit of restructuring. Right now we are at a point where I think there needs to be some kind of change in terms of the rendering pipeline that we have. I just have to check some streaming stuff here. Up, 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 up. Okay, I think I got most of it sorted. Yeah, I think so. Anyway, uh, uh, yeah. So, uh, I'm kind of looking at different articles and considerations in terms of previous experience. So yeah, NVIDIA here has made an article in terms of GPU performance hotspots, and we will end up discussing a bit of constant buffer stuff. The problem that we're trying to solve right now is um, um, how to structure our overall. Are there any online drawing tool? Sketchpad.io. Okay, let's see. I haven't used this before. There we go. Let's try using this. Do we have any shapes, layers, pencil, star, clip art, squares? And the outline, maybe set that to red. Anyway, whoops. There's no way of drawing it evenly. Not there any tools. It kind of weirds me out that it flies all over the screen whenever I draw it. Well, maybe. Yeah. Don't we have a sort of elements? It feels a bit cluttery and stiff to use. All right. Yeah, this is a detour. I mean, I like this tool and the layout, but I prefer for it not to hotkeys. Snap to guides. Well, that is probably a bit better. Let's see if we draw something like, well, it doesn't snap to anything. It just flies all over the place. It's a shame. Maybe it's implemented in. Maybe this is fine. Okay. Hmm. Well, Yeah, and this doesn't erase. It's just a pen of sorts. I don't really like this. It's so cluttery. Oh, layout. Well, so far they all look fairly familiar. Well, maybe I just use paint. Yeah. Online. Sketchpad. Let's try that. Sketch.io. Uh, they all look the same. Okay. Never mind. I'm not going to use any of those tools. We will use good old paint. There's no settings, right? Full screen. Okay, we can use full screen. We don't need that for now. We don't need the rulers. Okay, whatever. So we have our rendering pipeline here. Excuse me. Where we have the update plus draw calls. For and we have our different pipelines. I don't know where to. But in general, when we do draw calls, this is the whole render step for the whole application. Um, We of course set the viewport and the sysdirect for that viewport. Before we do anything, of course, we prepare the render target views and set up our swap chain stuff, rather related stuff. So we transition the render target for the frame that we currently want to draw. We clear it. We get our handles. We also clear our depth sensor view. And we set the current render target. Then we bind a specific pipeline. This is for polygons. We set the topology. We set the specific vertex and index buffer. And then we start our draw calls. So each frame will have a set of different buffers that is bound to the pipeline. This pipeline uses our pass data for us to be able to translate the vertices into screen space. We need some information, and we can look that up. Let's see. Not like that. For instance, oh, well, in our render data structure, we have a struct that holds our information. We try to align it so that we preferably use 128 bits alignment. We store the view projection matrix, the camera position, since we need that for different computations, and then we store the delta time value, and then we store some light data. It pertains to all the lights in the scene, and we simply bind that to our pipeline. I don't think we actually need to bind it every time, since the root signature doesn't change right now, which might be fine. Sometimes it's preferable not to change the root signature. We could definitely test out that in the future, where we might have something that is more performance intensive. We also set the descriptor heap information, tell the system where to look up different descriptors. Let's see, I think the CSU heap, it's for the constant buffers, is it? I think so. It's a long time since we actually created it. Let's see. Am I creating it? No, I'm not creating it there. Let's see. Okay, where the descriptor heap should be created on Uh, uh, let's see. We don't create it during this step. I usually would think that we create pipelines. Excuse me. Hmm. Well, we might not. Well, that is weird. I, I do think it's during initialization. I'm just missing it probably. Let's do this slow. Root signature, viewporting. Oh, no. We create a depth stencil view heap. Ah, there it is. Yeah, I missed it. So it's the CSU is short for constant buffers, um, shader resource views, and unordered access views. So yeah, we initialize it during the initialization step. So yeah, it's the descriptor heap of all descriptors that is bound to that specific what do you call it? That specific uh, yeah, where you store the different resources needed for this draw call. So we bind the descriptor heap, and then we start doing something that uh, handles our draw calls. And this is where, let me just change the music here. It's a bit too ambient for me. There we go. So right now we have something like a render item, something called a render item, which is a data structure. Is it stored in here? No, I think it's stored in the renderer. So we have these different data structures that contain our draw call specifics, and some of it is kind of like, well, maybe not optimal in terms of how we want to structure things. Right now, we simply create these render items and we iterate over them we have a way of creating additional render items, and we would have to create a way of deleting them as well. Usually we have during the update step, but yeah, I'm finding it kind of wonky. The problem is that we might have object-specific information, like how many indices are in this particular mesh. How do we find it in the index and vertex buffers? And besides that, we also need to bind our information in terms of materials, transform matrices. I think, for instance, we store the object information in the world matrix, and we store the texture transforms as well. Let's see. And we kind of bind that. We also have something called material data, where we specify the specific index. And let me just store that for later. But the problem is that we kind of like need this, excuse me, render structure to be updated and manipulated, and it's not very flexible. Because right now we have created a UI where we can change the texture, for instance, but we need to develop a way where we can kind of like, I know he's bouncing a bit. We will fix that when we get back to the physics engine. Anyway, we kind of want to be able to, for instance, pop in a new object. Maybe we want to create a new wall, for instance. So, for instance, if we wanted to add a new wall somewhere, and we draw that to the screen, we would right now have to go through a method where we kind of like submit a object here. And we expand our buffers. And we copy our information. And that's all right, but we also manipulate this vector here. And yeah, let's see. If we compare it to the way that we draw text or draw the UI, I know it's a bit more simple, but we can actually do something way more simple. We have a split. We don't need this actually. I'm pretty sure. Let's see. Let me see. Did I just D3D12 primitive? Maybe we can actually use the triangle strip here. Five. Maybe it's just yeah. Maybe it doesn't have a DirectX12 equivalent update. Anyway, we simply set the texture. Yeah, I think we might want to change this as well. We simply set the texture, which is not great. We would kind of like for the information to be passed to the pipeline directly, so we could maybe just use, well, I guess you would always have to bind the resources, but for instance, we simply know how many elements we have to draw. We know they have 4 vertices per instance, and we simply draw them. This is an instanced draw call, which means that it's good for batching. But yeah, the general idea is that we simply each frame update the buffers, update the current length of the buffer that is structured in such a way that we can kind of like store a lot of data in it and simply just iterate over it in our batch call, meaning that we specify where in the buffer, which is the same buffer. This was one and the same buffer. We simply specify how far into the buffer we want to step, and we reset the kind of like bounds for that specific frame. And that makes data submission for the UI fairly easy to implement. We can always add UI elements, remove UI elements. From frame to frame. There's no need to create a data structure to hold the information. So this means that it's fairly easy to, for one, update the information for each frame, and it's fairly easy to render the primitives. This uses the same method. Whenever we want to draw points, we simply could simply use this. Yeah. Anyway, yeah, this makes our draw calls more flexible. We do kind of the same thing here as the polygons here. So there has been kind of like, and this is just hard coded. But yeah, we would definitely like that the debugging information here, even though it might be a bit cumbersome, we would like kind of like the same API layout. Also because in the future we might use something called frustum calling, which means that the CPU does a bit of work in terms of determining what's outside the viewing plane of the camera. There are definitely more advanced ways of doing that, but we won't be doing that for now. since I need to figure out how to experiment with GPU based calling. But anyway, this means that whatever needs to be drawn might be changed from frame to frame. And kind of like having to pop out a item of this, resize the vector and so forth is probably not what we want. So although this is fine for the application to be able to draw different stuff, I'm just gonna stop playing the music because it kind of like feels too noisy. Maybe I had too much coffee. But yeah, we need to find a way to structure this information flow so that we simply submit whatever we want to draw. And copy the information. Yeah. But yeah, we need to take in consideration different factors. If we just read into this article, so yeah, they updated the DirectX 11 pipeline to support not updating the constant buffers, or rather reduce the overhead related to updating the constant buffers. Yeah, so we could to requirements to render a primitive. We would need something like vertex and index information in regards to global buffer on the GPU. We need that. We also need something like binding of material and texture information per object. And let's see. Oh, I didn't know that you could do that. Okay. Oh well, I didn't know. Oh, whoops. Binding of the material and texture information in the future. Perhaps PBR related information. And right now we do one buffer of each to every draw call. We could do some kind of indexing into an array of the data structures. This, of course, needs to be something like render. Oh my god, I'm so bad at writing render. There we go. One architecture. Is it spelled that way? Arch. Could be one big buffer that is offset based and updated each frame. Another, currently what we have, separate buffers that get updated per object basis. There's some reusability here. But this is more flexible, where you simply allocate a buffer, then for every visible object, you kind of like fill the buffer with all the information. The buffer also contains some indexing in terms of, for instance, textures and materials, which is just could be allocated into. Yeah, hello. Um, we are rare people. Um, it's also a lot more work, so I don't blame people who use OpenGL or DirectX 11. um, so yeah, the trade-off is like a more flexible system, but potentially reducing reuse of the buffers. I'm actually considering looking into how um, the DirectX toolkit or uh, tech demo provided by, I think it's Microsoft, actually does things. Um, yeah. Uh, yeah, so I've never used DirectX 11, but it seems like you had specific constant buffers for each draw call. And when you wanted to update the specific buffers, you would have to map and unmap um, the buffer so that the CPU could write to it. And since um, this article here, I think, illustrates how in DirectX 11 handles the constant buffers. The amount of CPU cycles to submit a draw call is very low compared to actually setting the constant buffer and even mapping and unmapping the constant buffer. So this was part of what ate the CPU performance side of things in DirectX 11. Also, you could call the update resources, and you would also end up in a situation where you would uh, have potential cache misses. So they updated the way of doing things in DirectX 11.1 and DirectX 12, and since I haven't used DirectX 11, I'm actually unsure how they did, but um, I'm interested in learning how the performance penalty arose compared to what we do now, because um, if the structure in the DirectX11 model is in such a way that, let me just expand this canvas a bit. So if we actually have a situation where I simply allocate a wait, oh, escape cancels that. I like the updates to paint, but I have to kind of like learn how to use them. But if I'm reading this article correctly, yeah, this is not even at all, but we could have something like a C1, a C2, a C3, and a C4, C5, and so on. If this could just be a sort of buffer that is controlled by an index slash offset, and there's no performance penalty for copying information directly over to any of these slots. In terms of efficiency, it's probably just fine to iterate over them all. But anyway, if this is the way that it's handled and there's no performance penalty to like having an array of constant buffers, which is simply offsettable in terms of the specific index, well, then we could just every frame update one big constant buffer with enough space for either the amount of objects or until the maximum limit of I think it's 64 kilobytes for a constant buffer. Otherwise, we would need a new page of constant buffers, which we would have a page handling system for. But yeah, I need to figure out if this is the case, because then we will definitely do dynamic indexing and one big constant buffer. Yeah. So this one, I'll just look up. There we go. Start slot. Start slot. Okay, it seems. Okay. Yeah, so this seems like a indexed access to the buffer. Oh, okay. Thanks for the advice. Maybe I'll do that in the future because I think the shader model 6.6 DirectX12 isn't the is it part of the yeah, it's about the agility SDK, and I haven't implemented that yet. Um, but yeah, yeah, yeah. I don't know why, but maybe I'll do that in the future when and if we decide to play around with ray tracing. I think the agility SDK is needed anyway to do that properly. I might need a new GPU for that. So it will come in time. Uh, but yeah, so I'm thinking that let's see. Uh, let's just look up this. uh, yeah, I need to be a bit more certain. Yeah, I'm allowed to. Hmm. Yeah, I think I'm allowed to offset. I don't think I need to have a vector of these. I think I can just allocate one big buffer, which has slices of data structures underneath it. Yeah. Updating constant buffers. Maybe someone more clever than me wrote something about it. Uh, okay, this is exactly what I'm messing around with. We could also use the structured buffer approach with instance drawing, and then simply just align the data structures with 16 bits, I think, since NVIDIA prefers that, at least on older GPUs. Hmm. Uh, Yeah, I'm just hanging out and reading a bit. Hello. It's quite all right. I'm just doing reading anyway, so yeah, not much going on. No, 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 don't worry about it. You're not obligated to drop by the stream, even though I love your support. Yeah, I'm actually trying to restructure the rendering pipeline so that um, it allows us to do object submissions a bit more elegantly. Yeah, 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 exactly. That's why I did the UI implementation. I just need to, for instance, I can change the texture here on the floor by a click on the UI, but I need to bind these two systems together in a more reasonable way because right now the systems aren't coupled in a great way. So I'm just reading into different articles on how to do proper buffer updating. I'm not sure I understand. All right, I think this is something along the path of handling dynamic and static constant buffers differently. I think I saw that previously in terms of the descriptor heap. Uh, yeah, that's exactly the plan. I'll do that um, in the future. It will have both mouse and text input. Oh, it's fairly easy actually. I have all the structures for it. The rough part is the dynamic linking of the renderer to the CPU side data structures. So once I kind of like decide on a design for object creation and deallocation on the renderer side, things will be fine. Um, um, I am working on changing, let me see, this method here, and the resulting draw calls for primitives. So I need to restructure the renderer a bit. I'm just considering how to do it because Yeah, I need to handle that. Hmm. I think we need to restructure the renderer a bit in terms of developing some systems for it. I might not be able to do it during this stream because I got to go do other stuff today. But yeah. Yeah, sounds nice hanging out. Okay, so yeah, of course. Yeah, so this would allow us to yeah, so you basically bind the resources every frame, which um, sadly doesn't allow us to reuse previous frame resources, but instead allows us to dynamically select objects for drawing, and the reuse thing is probably not viable once we start doing culling anyway. So yeah, you would have exceptionally large buffers where you can hold every object that you currently have loaded in, and then you would have to find some way of mapping or selecting. Yeah, I think the dynamic approach is better, and then have one large buffer allocation which we offset into, as I've mentioned previously on the stream. Let's see. Okay, so if I just store it in the upload heap, I won't run into synchronization problems. Yeah, on the GPU, or rather the default heap, I would need to do it differently, but I'm not doing that. Yeah, we don't want to store them in the default heap. Okay, so a emerging structure starts to appear. Uh, emerging structure starts to appear. I don't know if you can say that without being, yeah, saying something that is nonsensical or essentially the same, but yeah. Okay, here's a dude suggesting per instance data. Okay, this dude. Well, okay, the instance buffer is on the upload heap. Well, this is somewhat the same actually. Let's see. Oh, it's not the same dude. Let me just see. Uh, 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 well, this is not. Mm. Okay, so this is, for instance, if we do something like maybe rotate the object for some kind of, yeah, effect or whatever. If we draw objects from different perspectives or, yeah. It's pretty fine. How about you, man? Okay, I could definitely do this. Okay. It's a pretty long. Okay, okay. I think we're starting to get there. So, I think we will need something like a series of systems. Uh, we need a system that is sort of like a constant buffer, memory manager, GPU side. Uh, um, yeah, with page allocations, per frame, resets. Per object, stack, support of different data structures. Yeah, so the idea is that whenever we want to do our update step, application, we do We do simulation, then we do perhaps calling, then we do a render submission, submit list of visible objects. And this step, render submission on the renderer side, needs to well, static objects shouldn't change, meaning that we do what we currently do, but okay, let's see. Handle static. Well, maybe render submission is not. Let's see. So we have the update step. Before that, let's just move this. We would have a what we're currently doing, create on load level. Just an example. We create static objects, both application and render side. Okay, if we do application steps over here, application side, or at least using the application. Let's increase the size of this one. Yeah, and then on the render API side, over here, we do yeah, that's a hard word to pronounce. Equivalence, I guess. Create static resources, constant buffers for objects that do not change. Upload information to the GPU. Create a per frame structure that handles draw calls. Okay. Let's just insert some kind of well, some sort of boundary here, because this is done during um, some sort of preloading state of the application. We do this on the update/render step. Let's do update render. Assign constant buffers for dynamic objects. Copy the data from the this CPU side. Create draw call information per frame. Maybe we do this for every frame. So we will essentially have we will use a page system meaning that we will allocate pages of one single overall buffer, and we will use offsets into that buffer. Um, I'm writing this stuff at least in part for myself to get an overview on which systems that we need to do, and if anyone in the future watches these videos, I'm explaining what we need to achieve. So yeah. I think that is it, at least for now. So This allows us to draw objects dynamically. Of course, when we're in edit mode, most objects will be dynamic because they might change even on a frame-by-frame basis. So this allows us to draw a frame dynamically or uh, effectivize or performance optimize um, the rendering of a kind of like pre-baked level. Uh, yeah, this also allows us to maybe we even want this subsystem to in the future actually handle also these static objects. Maybe we want the static objects to hold a flag whether it's called or not. I don't know if that's reasonable, but yeah. The next thing that would have to be tackled in terms of calling and so forth would be streaming and loading of different things. You could preload the level beforehand, or you could stream the contents dynamically in two appropriate buffers. But okay, so there will be no deallocation, reallocation, remapping stuff here. We would simply whoops, do that. All right. Mm. Oh yeah, this is actually the explanation of the difference between DirectX 11 and DirectX 12 that I was contemplating earlier, which is referenced here. It's more in detail here. Mm. Yeah, bundle memory records of data in a single buffer. Okay, that is great. I do think that the way of handling the different information here needs to change as well. Okay, I'll have to go in a short while since I need to do some stuff, but at least now I have an outline. So I think that our system here, I will do something like a render subsystem, uh, where we simply, yeah, I'll be going too, so it's definitely no problem. It was nice, as always, to have you hang around and interact. This stream has been more of a design process overall, so yeah, not much going on anyway. Excuse me. Okay, so the render will have a subsystem where we kind of like allocate Yeah, I'll be gone in 20, 15, maybe even 10 minutes, since I need to go do some stuff, and I'll be away maybe, yeah, even through the evening, and yeah, I'll probably be back on the 25th. Yeah, but once again, thanks for hanging out with me. So we need to allocate. I'll be on the lookout. Fingers crossed nothing happens. And you don't have to, of course, but as long as you want to, of course, feel free to tune in and just hang out. Uh, so we allocate on a. I'm happy to hear, man. Um, so we will have a renderer subsystem that allocates on a per frame basis and supports static non-changing allocate. See you around and take care. Have a great one. We draw calls for specific pipelines. Right now, we won't support a lot of instance drawing. I don't think, at least. Yeah, future stuff. Handle instance drawing. Separate. maybe structured buffers instead. So we will create a subsystem that handles and stores these rendering items, so to speak, um, inside itself. It will be managed by a internal memory layout and with per frame resets, where we simply allocate draw calls for each frame, then deallocate. We could also do triple buffering, or rather triple frames in flight. System needs to support triple, double, or triple frames in flight. Constraints. Functionality. Let's do something like this. A buffer that stores draw calls, allocate per frame basis, subdivided into dynamic and static parts. Let me just managed heap allocation that is preserved during application lifetime. System with root pointer and iterative and increment pointer reset every frame. Yeah, so the renderer will have a subsystem where we simply store these things. We could maybe even bind the vertex index buffers to this subsystem. Pipeline. Yeah, so it would have to be coupled with the maybe coupled with the mesh system. So for instance, we simply submit the same game object here. Um, well, we kind of like, we will do somewhat the same. We will just implement a underlying system both for the constant buffers and the actual render item information, which will allocate and deallocate each frame. And it won't deallocate anything in reality. It will simply just start over in whatever buffer space we have, write the data, then use the data. Yeah, so this is instead of using the vector system itself, although it will be somewhat of a yeah, it's basically like a vector, but you overwrite for each frame. Yeah, so that will be fun to implement. Yeah, I would like a bit more control over our memory stuff, but yeah, and this will just be some kind of page system where we create another API for the constant buffer stuff. Let's see. Yeah. All right, I'll start working on it during the next stream, I think. Then we will do some rework to the constant buffer information for each object. It will store the material index and texture index so that we simply bind probably just a descriptor table. Yeah. And all the materials and textures will be bound to the pipeline by descriptor table. Yeah. I think that's the way to go. Then we will end up with something like only this will be left. Hopefully. And maybe this one. Yeah. We would simply offset into the appropriate page and subbuffer offset. Yeah, I think that's the way to go. Not much will change, but during our update step here, we will have something like a submission of our dynamic objects. The CPU side will generate a list of dynamic objects that needs to be drawn this frame. Yeah. Once you generate lists like this, you could also subdivide them, different draw calls if you had a lot of objects into different threads. But yeah, I don't know if we ever end up being in a position where we need to do threading. We'll see. Anyway, this has been a long stream where I actually didn't do any programming. It's just a bit of planning in terms of what systems to implement so that we can get to a place where the system supports dynamic rendering, so to speak, meaning that we can upload whatever elements we want to draw each frame, and yeah, we should also change this system here so that we can toggle the bounding volume debug information But that is work for another day. Thanks for dropping by if you did that, and I apologize for this stream being a bit too slow. I just needed to collect my thoughts on how to do things in terms of the actual refactoring. Yeah. Hopefully I'll do some more coding in the future. And if you don't mind streams like this, where we browse different resources and contemplate different design decisions in terms of planning out how to interact with the hardware, well, then feel free to comment, even like or subscribe. Yeah, hopefully I'll be seeing you around here on the stream. Take care and stay strong. I'll see you around.